The breath of life. In previous discussion about the cosmos, it was noted that man could be described as the microcosmos, and that organic life on Earth is the tritocosmos. Then further it was pointed out that each cosmos experiences time in a different manner, or on a different scale, which can then be associated with breath, where in this context, a unit of breath is equivalent to 1 unit of time in that scale. Man in a normal state takes about 20 full breaths, that is inhalations and exhalations, to the minute. A full breath for us therefore takes about 3 seconds. Sleep and waking are then regarded as the breath of organic life on Earth, where for mankind, and for all organisms living in similar conditions to us, even for plants, a full breath is represented by a 24-hour cycle. Sleep and waking are in this manner regarded as breathing for organic life, because plants when asleep, which is at night, exhale, and when they are awake, which is during the day, they inhale. In exactly the same way, for all mammals, as well as for man, there is a difference in the absorption of oxygen and CO2 by night, and by day, in sleep and in waking. Reasoning thus, it is logical to arrange the periods, or cycles of breath, sleep and waking, in the manner illustrated. Applying a simple rule of 3, we can then divide 24 hours by 3 seconds, giving 28,800. Then by dividing 28,800, which is 1 day and night cycle, by 365 days, we get close to 79 years, which represents the lifetime of a human being. This parallel can be continued further. Again multiplying 79 years by 30,000, and rounding it up, we get a little less than 2.5 million years. Then multiplying 2,500,000 years by 30,000 we get a number of 11 figures, or 75 billion years. So far, these figures appear to be logically feasible, with 2.5 million years for organic life on Earth, and 75 billion years for the planet itself. However, later there are cosmoses lower than man, so let's examine how they stand in relation to this. Taking 2 cosmoses to the left side from the microcosm, and understanding by them as first comparatively large microscopic cells, and then secondly smaller, and so admissible, yet almost invisible particles. Such a division of microorganisms into 2 categories cannot be said to be accepted by modern science. However, if we think of dimensions within the micro world, then it is impossible not to accept that this realm consists of 2 worlds, as distinct in themselves, as the world of people, and comparatively large microorganisms. 24 hours would then represent the life cycle of such a cell, and although the period of life of an individual cell can in no way be considered as established, science has revealed that for a specialized cell, such as those of the human organism, the period of life appears to be approximately 24 hours. The breath of this cell then equals 3 seconds, which tells us nothing yet. However, that 3-second lifespan of a particle tells us a great deal, and it indicates above all why it is so difficult to see these particles, although by their size, they ought to be accessible to vision using a good microscope. Working with these figures further, we see what would happen if we took breath, which is 3 seconds, and divided it further by 30,000, giving 1/10,000th part of a second, the period of duration of an electric spark, and at the same time, the period of the shortest visual impression. For convenience in calculating, and for clarity, 30,000 is taken instead of 28,800, and the coefficient rounded up. 4 periods then appear to be connected with, or separated from one another, by one and the same coefficient of 30,000. The shortest visual impression. Breath, or period of inhalation and exhalation. The period of sleep and waking. The average lifespan. At the same time, each of these periods appears to denote a corresponding, but lower period in a higher cosmos, and a corresponding, but higher period, in a lower cosmos. Taking this further, we can attempt to make a fuller table, and bring into it all the cosmoses, which is to add 2 more of the lower ones. The first of which is the molecule, and the second is an electron. Then again, for clarity when multiplying by 30,000, we can take only round numbers, and only 2 coefficients, i.e. 3 and 9. Thus 2,500,000 is taken as 3 million, 75 billion is taken as 90 billion, then 79 as 80 and so on. The coefficient of 30,000 may appear too big, but at the same time, remember that the relation of one cosmos to another is as 0 to infinity, and in the presence of such a relationship, no coefficient would be too big. The relation of 0 to infinity is the relation of magnitudes of different dimensions. Every cosmos is 3-dimensional for itself, which means that the next cosmos above it is 4-dimensional for it, and the one below, 2-dimensional. The next one above that, 5-dimensional, and the next one lower, 1-dimensional. One cosmos in relation to another is a magnitude of a greater, or a smaller number of dimensions. However, there can only be 6 dimensions, or with 0, 7, but by the table illustrated, 11 cosmoses are obtained. At first glance, this appears strange, but only at first glance, because as soon as you take into account the period of existence of any cosmos, in relation to higher cosmoses, then the lower cosmoses disappear, long before reaching the seventh dimension. Take for example man, in relation to the sun. The sun appears as the fourth cosmos in relation to man, taking man as the first cosmos. However, man's long life, of approximately 80 years, is equal in time to one electric spark for the sun, one of the shortest possible visual impressions. Each cosmos is an animate and intelligent being. Each cosmos is born, it lives, and then it dies. In one cosmos it is impossible to understand all the laws of the universe, however 3 cosmoses taken together, include in themselves, all the laws of the universe. Or 2 cosmoses, the one above, and the one below, determine the cosmos that stands between them. By passing in our consciousness to the level of a higher cosmos, we, as human beings, by this very fact, pass to the level of a lower cosmos. Here in each word, lies a clue, to the understanding of the structure of the world, however there are yet many clues to grasp. How then does movement, from one cosmos to another appear, and where or when, does that movement disappear? In what relation would the figures stated in the table shared, stand to the more or less established figures of cosmic movement? As for example, the speed of movement for the heavenly bodies, the speed of movement of electrons in an atom, or the speed of light, and so on? When we begin to compare the movements of various cosmoses, we get some surprising correlations. For example, for our planet Earth, the 24-hour period of the rotation on its axis is equivalent to 1/10,000th of a second. For man, that is the speed of an electric spark. It is doubtful, therefore, whether at such a speed, the Earth would notice its rotation on an axis. If man rotated similarly, then rotation around the Sun would occupy about 1/25th of a second, the speed of a still photograph. Taking into consideration the enormous distance that the Earth has to traverse in this time, the inevitable inference is that the Earth could not be conscious of itself, such as we know it, which is in the form of a sphere, but that it must be conscious of itself as a ring, or as a long spiral of rings. The latter is the more probable, using a definition of the word present, as the time it takes to draw one breath, which is what comes to mind when time is defined as breath. Starting from this, we could say that breath may be regarded as a unit of time, that is to say, for direct sensation, the period of one breath is felt, or perceived as the present. Supposing then, that the sensation of self, which is of course one's body, is connected with the sensation of the present, then we come to the conclusion that for the Earth, with one breath in 80 years, the sensation of itself should be associated with 80 rings of a spiral, that are circumnavigating the Sun. Passing to the lower cosmoses, that is, to the cosmoses in the table illustrated, that stand to the left of man, we see in the first of them, an explanation of what appears to be the astonishing speed, almost instantaneous, with which some of the inner processes of our organism work. A person who gives thought to questions of physiology may not be astonished by the fact that the effects of drinking a cup of coffee, or a glass of brandy, the inhaling of the smoke from a cigarette, can be felt immediately in the entire body, changing all the inner correlation of forces, and the form and nature of reactions. It ought to be clear to such a physiologist, that during this quite imperceptible interval of time, approximately equal to one breath, a long series of complicated chemical and other processes are accomplished within our organism. The substance that has entered the organism is carefully analyzed, the smallest divergence from the usual is immediately noticed, and in the process of analysis, it passes through a series of laboratories. It is resolved into its component parts, and mixed with other substances, then in the form of these mixtures, it is added to the fuel that nourishes the various nerve centers. All of this must occupy a great deal of time. The seconds, in our time scale, during which all of this is accomplished, make it a fantastic and miraculous phenomenon. However, the fantastic side falls away, when we realize that for the large cells, that obviously govern the life of our organism, our one breath continues for over 24 hours. In 24 hours, even in half the time, or a third of 8 hours, which is equal to 1 second, it is possible to imagine all the processes that have been indicated, being completed in an orderly manner during one shift. Exactly as they would be in a large and well-arranged chemical factory, with various laboratories at its service. Passing further to the cosmoses of small cells that stand on the border, or beyond the border of microscopic vision, we can again see an explanation for the inexplicable. For example, cases of almost instantaneous infection, by epidemic and infectious diseases in general, particularly those where the causes responsible for the infection, have not been found. If 3 seconds is the limit of life for a small cell of this kind, and equal in proportion to the long life of man, then what would be the speed at which these cells multiply, when for them 15 seconds would be the equivalent of 4 centuries? Passing to the world of molecules, we come face to face with the fact that within the brevity of the existence of a molecule lays an almost unexpected idea. It is usually supposed that a molecule, although structurally very complicated, taken as the basic so to speak, is the living interior of the building blocks, from which matter is built up, existing for as long as that matter exists. We are however obliged to part from that comforting thought. The molecule that is alive inside us cannot be dead outside, and in remaining alive, it must, like everything living, be born living, and then die. Its term of its life equal, on our scale, to an electric spark, or to 1/10,000th part of a second, is too small for it to act directly on our imagination. So some comparison, some analogy, is therefore necessary, in order to understand what this means. The dying cells of our organism, and their replacement by others, bring us near to this idea. Dead matter, i.e. iron, copper and other minerals, must be renewed from within more quickly than our organism perceives. In reality it changes before our very eyes. If you look at a stone, shut your eyes and immediately open them again, it will not be the same stone that you previously saw. Inside of it, not one single molecule that you saw the first time, will now remain. Furthermore, even then, you did not see the molecules themselves, but only their traces. Then in the last cosmos, which is the world of the electron, we can feel from the very beginning, the world of the sixth dimension. The electron, as a three-dimensional body, is too unsatisfactory. As to begin with, it exists for 1/300 millionth part of a second. That is, a quantity far beyond the limits of our possible imagination. It is considered that an electron within an atom moves in its orbit with the speed of 1 divided by a 15-figure number. Since the whole life of an electron in seconds is equal to 1 divided by a 9-figure number, then it follows that during its lifetime, an electron makes a number of revolutions around its sun, equal to a 6-figure, or, taking into account the coefficient, a 7-figure number. If we take the Earth in its revolution around the sun, then according to this table, it makes, in the course of its lifetime, a number of revolutions around the sun, equal to an 11-figure number. It looks as though there is an enormous difference between a 7-figure and an 11-figure number. However, if we compare with the electron, not the Earth, but the planet Neptune instead, then the difference will be considerably less, namely the difference between a 7-figure and a 9-figure number, that is a 2-figure difference instead of 4. Aside from this, the speed of revolution of an electron, within an atom, is a very approximate quantity. It should be remembered that the difference in the periods of revolution of the planets around the Sun in our solar system represents a 3-figure number, because Mercury revolves 460 times faster than Neptune. The relation of the life of an electron to our perception appears thus. Our quickest visual perception is equal to 1/10,000th of a second, or an electric spark. The existence of an electron is equal to 1/30,000th of 1/10,000th of a second, that is to 1/300 millionth part of a second. In that time frame, it makes 7 million revolutions around a proton. Consequently, even if we were to see an electron as a flash in 1/10,000th of a second, we would not see the electron in the strictest sense of the word, but only the trace of an electron, consisting of 7 million revolutions, multiplied by 30,000, which is a spiral, with a 13-figure number of rings. Expressed in the language of the new model of the universe, this represents 30,000 recurrences of the electron, in eternity. Likened to this the Buddha, noting on lifetimes, that if the bones of each of our incarnations could be piled in one place, one upon the other, then we'd observe a mountain before us, representing all of our lifetimes experienced.